Okay, so this way is just create a common denominator. In order to do that, I need to multiply this denominator by top and bottom of this one, and take this denominator, 1 minus cosine, and multiply it by the top and bottom of cosine x over sine squared x. So that is how you can always create a common denominator and push two fractions together. So the first thing I'm going to do is I'm going to take sine squared x and multiply it by the other fraction. So sine squared x times 1 would just be sine squared x over sine squared x times 1 minus cosine x. I'm not going to distribute until I know I have to, so I'm going to leave it as sine squared x times 1 minus cosine of x. Now I'm going to take the other denominator, 1 minus cosine x, and multiply it by the other fraction. That's going to turn into cosine x times 1 minus cosine x. And on the bottom, just like we wanted, is going to be sine squared x times 1 minus cosine x. Now, pushing these two fractions together, I'm going to distribute that cosine just because I know what's going to happen. I'm going to save some space and combine the numerator. So I'm going to have sine squared x, and here we have to be careful because it really is negative cosine x being distributed. So negative cosine x times 1 is going to be negative cosine x, and negative cosine x times negative cosine x is a positive cosine squared x, all over sine squared x times 1 minus cosine of x. Well, the cool thing here is I have sine squared, I have a cosine squared, they're both positive, so I can push them both together, get sine squared plus cosine squared, which equals 1. So picture me putting this cosine on the other side next to this sine. I have sine squared plus cosine squared equals 1. So moving down a little further down here, we have sine squared plus cosine squared is 1 minus cosine of x all over sine squared x. That was a terrible squared, but we're going to leave it. 1 minus cosine of x. My numerator and denominator turn to 1, which equals 1 over sine squared x, which equals cosecant squared x. Who did it that way?
I attempted.
So your attempt could have worked, as long as you stuck with it and did stuff correctly. Did the rest of us see that we had 1 minus cosine x? Is that kind of the prevailing? Yeah. So that's another great way to do it, is to recognize that we have 1 minus cosine x. Anytime you see 1 minus cosine x, 1 plus sine x, 1 minus sine x, something like that, you should think conjugate. But if you didn't see that, pushing them together worked also. So I'm thinking conjugate here. Multiply the top and bottom by 1 plus cosine x. So that will change this fraction to 1 plus cosine x over 1 minus cosine x times 1 plus cosine x. So this is the other way. I didn't do anything to the other fraction, so it's still cosine x over sine squared x. Well, the whole reason we do a conjugate is because it's a difference of squares. So that denominator right here is going to turn into 1 squared minus cosine squared, or 1 minus cosine squared, which by now we should immediately look at and say, hey, that's just equal to sine squared. So this 1 minus cosine times 1 plus cosine will turn into sine squared x. The numerator is going to stay 1 plus cosine, and then we have minus cosine x over sine x. I'll have cosine minus cosine. That should be sine squared x. So cosine minus cosine is just going to be with 1 on top. 1 over sine squared x does equal cosecant squared again. Bingo, bango, boom, boom. We are done. This way's a little easier, but this is doable. This is very doable. So if you end up doing something a little too long, it's fine on the test. Just stick with it, all right, to finish it out. All right, so if I got to here and all of a sudden I realized, oh, I should do a conjugate, maybe I should finish it here. It might be quicker than starting all over again. Okay, so 2 methods. You should know how to do both methods. You should be able to look at 1 minus cosine and think conjugate. And you should also, in the back of your mind, think, well, I can also push fractions together. So you should have been able to see kind of both methods. Yeah?
So conjugate only works for one, like, fraction? Like one part of the fraction?
One
Like,
part.
you didn't multiply the conjugate by to the other side.
I did it to the top,
No, but on the other.
to this fraction.
It's like not finding the common denominator.
Well, it turned out it worked as the common denominator. I just multiplied the top and bottom by conjugate, and I hoped it worked out, and it did. If it didn't work, if it didn't create a common denominator, then I'd have to do something else. So if this would have been like sine cubed x, and this just turned into sine squared x, I gotta do something else. All right, it just so happened that this time multiplied by the conjugate, and you don't have to multiply it by the other fraction because they're not tied to each other. The only way to have to multiply it by the other one is if the fraction went all the way across. You can deal with one fraction at a time, because I'm just multiplying by 1. I can multiply this by 1, I can multiply this by 1. Okay? Other questions on this? No? All right, questions from the homework. Yeah, Lily. We can. We can, but I don't want to. Is that fine? All right. 67 was, I can't see my numbers, but I think it was it's like sine alpha was negative 24 over 25. All right. It came out to some weird numbers, and if you weren't using a calculator, you could easily make lots of mistakes. So this is what I did. So I immediately read that it was sine alpha minus beta. So I wrote this down to start off with. So you should have that written down. I assume you did. And then we need to find, well, they gave me a sine alpha. So we know sine alpha, we knew this value. Let me highlight the value that we knew starting off. I knew sine alpha. And I also knew cosine beta. So I needed to find cosine alpha, sine beta. I usually find whatever's first in there. So I find cosine alpha first. Cosine alpha equals square root of 1 minus sine squared alpha. And sine alpha was negative 24 over 25. And then I simplify it down.
I think I see my problem. I did the sine b first and I did plus 18/7 instead of minus. I did.
Oh, you did you distributed this negative
Yeah.
and made it plus.
Yeah.
Can't do that because you got to do the exponent first. PEMDAS, exponents first. And then, yeah. A good check on this, you should always have minus in here. All right, the plus will never cancel out. It'll always be minus inside here. All right, other questions? Questions going once? Going twice? This is a terrible one to record because we only had one question, but that's okay. If you're not here, you can ask questions. What was it? Yeah.
From where's the camera?
There's no camera.
What do you mean there's no camera?